All right.
All right, they're
We can
coming in.
start streaming
Good
too.
afternoon.
Got it.
Okay.
If all the students are coming in.
Okay.
Good afternoon. Welcome. Oh, now it says join with audio. Okay.
Yeah, I'm gonna just
Okay.
click that.
Okay. Are we good, Tony? Can somebody please unmute? He wasn't able to unmute himself.
More or less. There's a few others, but yeah.
Yeah. Can we unmute? Allow Tony to unmute.
Yeah, he has co-host ability. He should be able to.
Okay. Hey, Tony, you're muted.
Yeah, he should be able to come off mute as a co-host.
Okay. Yeah. Can we stop the live stream?
Sure.
We'll resume it when we're all set. Okay.
I don't know if he's getting the notification that it's on there.
Mm-hmm.
Um,
Um, it says, can you also, hey, Tony, are you coming in as Brenda? You're not coming in as Brenda also, right? No. Okay. What is the moon? Hey, Mr. Natividad, we're still streaming live.
yeah, I can cut it
Yeah,
when
can
I
you pause it until we're ready? Yeah.
Oh no, I'll post it. I'll put it. I'll cut it post and just have it shortened. You know what I mean?
Okay. Yeah. Okay.
Hey Tony, are you able to click on the mic to come off mute?
Okay.
Or Tony, are you getting the notifications when it says the host has asked you to unmute?
I don't think he can hear us.
Oh,
Yeah.
Okay, we'll try chatting direct. There's two of them though, so
yeah.
okay, so Tony host, let's see here.
I was gonna say that when the rover lands on Mars and you're gonna see that if people can live on Mars, how do you think that would work? How do you think it would
Wow,
work?
good question. We'll get to that question at 12:25. Thank you, Antonio. Thank you. Let's try to fix his mic in a few seconds, okay? Let's see.
Oh, it looks like he's getting a mic and headset ready.
Okay.
Okay. Let's see.
All right, everyone, let's be very patient. We have an incredible guest today. So
Yes, we're making sure that he can tell us all his wonderful presentation. He is connecting his mic properly.
How about now?
Oh,
yeah, okay.
I don't know how I got so many instances started on my computer, but I was in some, I think it was because I logged in from two different places. So
Okay.
hopefully I'm good now.
hey. Thank you. We're ready.
All right, I will share. I'm very sorry for all the technical difficulties.
That's okay.
Can you now see my presentation cover slide?
Yeah, absolutely. All right, so everyone, thank you again for joining us for Destination Space 2021. Remember, this month in March, we are taking you to the moon. Okay, we've already had a number of presentations. This is our third week, and today we have a very special guest with us. We have Dr. Anthony Colaprete. He is the planetary scientist and the lead scientist for the Viper project mission, for the Viper mission, which is a rover that we're going to be sending to the moon pretty soon. He's going to tell us all about it. So I know we had a little bit of a delay, so let's just get started. Everyone, please help me welcome Dr. Tony Colaprete. Thank you, Tony. Thank you for joining us today.
Thank you for inviting me. And yeah, I'm sorry we had the technical difficulties, but I'll try to jump right in and not waste any more time. So a general question I think I like to put out there for everybody is, and you don't need to answer it right now, but I'm going to answer it for you in a second, is there water on the moon? This is an interesting question, and one that has been contemplated for many, many, many years. So I don't know if you all think there's water on the moon, or maybe you've heard one way or the other there is or isn't. But it's an important question that I'm going to get into. This is what we believed up until recently. We've been to the moon with both robots, landers, and humans during the Apollo missions, of course. We've drilled on the moon. We've collected samples of lunar material, dirt and rocks, and brought them back to Earth to analyze. And when we looked at all those samples and analyzed the moon from afar, it looked dry. There's no atmosphere on the moon. Daytime temperatures can get up to 100 degrees centigrade, very hot. So there was it was really believed that there shouldn't be any water. You're in a vacuum of space because there's no atmosphere, so water just boils off. And so it was considered bone dry. Maybe 100 parts per million, meaning for every million pieces of dirt you picked up, you might find 100 molecules of water in the soil. Very, very, very dry. That's what we believed going back to the 1950s, 1960s. But about 15 years ago, that all changed. A number of missions were flown that indeed showed there was water on the moon, both on the surface and in the subsurface. And it's a really crazy kind of thing to think about, is how could water exist on the moon? As I mentioned, without an atmosphere and at warm temperatures, it should just boil off into the vacuum of space. And so there's a lot of people wondered, well, how we're seeing water, how could this be possible? And actually, the idea that water might be on the moon dates back to the 1960s when some scientists predicted that there would be craters at the poles of the moon that whose interior could get really, really cold. And so this is a picture of a crater on the moon. And you can see there's bright lit areas and there's darker areas on the inside. Without an atmosphere, the bright areas are going to be really warm and the dark areas are going to be really cold. So how could you have water at the poles of the moon in these dark craters? Well, it comes down to the tilt of the axis of the moon. Some of you might know that the Earth's tilt is about 23.5 degrees, shown in this picture here. By tilt, I mean if this was a ball, a basketball, and you're spinning it on your finger, it would be tilted away from the spin axis by about 23 degrees. That's this angle right here. And so that's what gives us a lot of our seasons. When the northern hemisphere is tilted towards the sun, it's summertime. When the northern hemisphere, the top part of this globe, is tilted away from the sun, it's winter. So that tilt drives the seasons. On the moon, that tilt is only 1.5 degrees. It's very, very small. So the sun is always very near the horizon at the poles of the moon. This is an example of what the sun would look like at the poles of the moon. And I'm going to actually jump here at the risk of breaking something to do this. Jump to, just stand by. Right here. No, go ahead already. I had it ready. Now it's gone. Nope. There it is. This is, yeah. So this is a simulation. I'll make this big. Hopefully you can still see this. This is a simulation actually that we made of what it would look like driving around at one of the poles of the moon. You can see these craters are all dark. You just saw the shadow of our rover there in a second. And as this rover drives along, you'll see it driving along. It's actually really like a cool video game. I mean, this is actually hooked up to driving consoles, and our rover drivers practice driving on the moon with this. It's using the cameras as the rover would actually see it. You can see right here the shadow of the rover. The sun's right behind us. And for the sake of time, I'm going to speed this forward a little bit. And here, there's the sun. The sun is super low in the horizon. And so what that means is that, let me get it to it just there. So if the sun's super low on the horizon, you can see some of these craters are in shadow. And no matter where the sun is in the sky, as the sun goes around the axis of the moon, the bottom of some of these craters are in shadow all the time. Literally for billions of years, they could be in shadow. And because there's no atmosphere, these temperatures in these shadows in these craters get very, very cold. And so that's how we call these permanently shadowed regions on the moon. And this just shows a graphic. This is a crater called Shackleton crater right near the south pole of the moon. And it shows that on the inside, it can get very, very, very cold. And just how cold, you might ask? Well, it turns out, this is a fun fact you can bring home to mom and dad, is the coldest place so far observed in the entire solar system is on our own moon. there are these craters, these permanent shadowed craters that are colder than Pluto. The coldest temperature measured so far is only about 18 Kelvin. So that's like minus 255 degrees below zero. Super cold. And when you're that cold, even if there isn't an atmosphere, water can be stable. It will stay frozen. It is so cold that it won't boil off even in the vacuum of space. So this is how we can have actual water on the moon, even though there's no atmosphere. And this just shows, this is a movie that shows, let's see if it plays, it may not play. This just shows the poles of the moon. This is the North Pole on the left, and this is the South Pole on the right of the moon. And it shows at one particular time of day. So the bright areas are sunlit areas, dark areas are shadow areas. And as the day goes, these different places are illuminated by the sun. But the areas that are pink here, those are craters that have these shadowed floors that are never in sunlight. So you can see there's lots of places at the poles of the moon that have no sunlight at all. And just give you an idea how big this place is. This crater here, this is Shackleton, it's about 20 kilometers across. All right, so 15 miles or so. These are big craters. These aren't little things. So all these cold craters could be holding water. Let's see, go to the next slide here. There we go. So why are we interested in lunar water? Well, there's a number of reasons that we are. And there's two primary categories that those reasons fall into. One is exploration. We want to go places and explore them. And often when you explore a place, you like to understand what resources are there that you might take advantage of. Sunlight is one. So just like I said, there's these places that are always dark. There's some places of the moon that are almost always lit for the same reason at the poles. And that provides good solar power. So sunlight is a resource we plan on taking advantage of when we go to the moon. Water can be a huge resource. It can be used for drinking water. It can be used for radiation shielding. So there's radiation in space, and water is a great shield against radiation. It can also be used to make rocket fuel. Water is made of hydrogen and oxygen. Those are two principal components in rocket fuel. So there's that side of things, the exploration side. We want to use the water as a potential resource to explore beyond Earth. The other reason is basic science. Water is a critical element, or molecule, I should say, in the universe. It's obviously pretty important to us from a life standpoint. Without water, we wouldn't be here. So understanding where the water came from on the moon, how to get there, why is it still there? Is that same water that's on the moon the same water that came to Earth? Those are all really basic questions we want to try to understand from a science standpoint, to understand how our solar system, how Earth and the moon formed and evolved together over history. So those are two really important reasons to go and understand water on the moon. You've probably heard of the Artemis program. This is where we intend to go to the South Pole of the moon in a sustained way. And we hope to use these resources, sunlight, water, and anything else we might need, to help us be there in a more permanent fashion, in a sustained fashion going forward into the future. So how are we going to do this? We're going to use the Viper mission. And some of my animations don't seem to be working in display mode. I tested them before, but the Viper mission, Viper stands for Volatiles Investigating Polar Exploration Rover. It's a mouthful. What it is, you see the rover right here. It is a four-wheeled rover, and you'll see more pictures of it later, that will explore the South Pole of the moon. And here's another video that I'm going to skip a second time. It's carrying, the rover carries a number of instruments on it, and these are the four instruments that it's using. It has a instrument that is like the nose of the rover, like a bloodhound dog. This instrument actually smells hydrogen. And as I mentioned, water is composed of hydrogen and oxygen atoms. This instrument here actually smells hydrogen underground. So as we're roving and driving, this thing is sniffing, looking for water, that hydrogen. When we find places that we're interested in understanding the water that might be at the surface or actually in the subsurface buried, we have a 1 meter drill. It's about 3-foot drill right here that actually will drill down into the subsurface, below the surface, and bring material up. That material is then looked at by 2 other instruments. One is, this is called a mass spectrometer. It basically can smell the various molecules. It can tell you what molecules are there. Is there water? Is there carbon dioxide? Is there a methane, etc.? This instrument called NERVUS has a lot of lamps on it. It's got all these lights, and you'll see it in the next figure, actually. This instrument here, it's got all these lights. We plan on driving the rover into these permanent shadow regions, and some instruments need actually lights to work. So this instrument called NERVUS, it is a NERVUS instrument, has this is a very expensive flashlight. This is a camera. These are LED lights that provide different colors. You see we have red and green. We have some that work outside of the spectrum we can see called the near infrared. And this instrument will actually tell us what the form of the hydrogen is that we smell. So we'll tell if it's water ice, or is it methane, or is it some other volatile like carbon dioxide or sulfur dioxide. So it tells us all about the composition. So these instruments are really important for helping us understand where the water is and how much is there. And I don't know if this is going to work. Okay, so this is an example actually we did in the laboratory of the drilling. So we're in this big facility at one of our research centers at NASA where we can simulate the moon's surface. And this is a big tube right here on the left here. You see this big tube of dirt. It's actually a very special dirt. It's meant to simulate lunar dirt. And we have some water in it, and it's frozen down to minus 200 degrees below zero. And this is a drill that's going down as seen from the NERVUS instrument. And you can see the cuttings pile. See that little stuff depositing out of there? That's material coming up from the drill and being put on the ground for the NERVUS instrument to look at. What all these squiggly lines are is telling us that we see water with each time the cuttings are brought up. Each of these little pointy spikes here is the instrument telling us, I see water, there's this much of it. And so this is how we've gotten ready, is by testing out these instruments in laboratories to understand how we're going to look for water. The next slide here. Now here's a prototype of the rover. So again, we have a final design for the rover that we're working towards and building. But always along the way, you build and you practice, build and practice. And this is a practice rover. It's a full-scale rover. It's the actual size. And what they're doing is they're driving it. Hopefully this will work. If not, I can jump to the actual video. Bummer. That's not working. So where they're at is at a test facility where they're driving it on soil that is, again, similar to the soil on the moon. It's very fluffy and powdery. And they're testing the suspension. These are pretty big wheels. These wheels here are 50 centimeters tall. So that's it's a 1.5 feet or so tall. So it's a fairly large wheel. And we're testing it to understand how it drives in these soils and mechanics. And I'll see if I can get once I bounce out of the PowerPoint, I'll see if I can get these movies to work, because I don't know why they're not working here. Here's an example where it's driving up a slope. Now this is kind of misleading because they had the camera fixed to the slope. But if you look over here, look at the whole building. The whole building's tilted. They didn't tilt the whole building. They actually tilted this platform. So it's kind of an optical illusion. But this rover right now is driving up a 25-degree slope. That's pretty steep. So we're really practicing a lot of ways of how to drive, testing the wheels, testing how the suspension of the rover works, etc. See. Get to the next one. So this is kind of my final slide here, and I can jump back and show the movies. Really, I wanted to show the movies because you don't want to see me talking about, squiggly lines all day. as a scientist, that's what I like to do. But what we're interested in with the Viper mission is understanding moon water. We've now known, after thinking the moon was super dry for many, many years, that there's actually water on it. There's water at the poles, there's water in dark places, and some sunlit places, etc. The next step is to really get down there and drive a rover around and understand exactly where it is, how much is there, and to do it the scales that we are interested in. You know, you can look at it kind of globally, but when you're using a rover, you can understand it on what I call the human scale, the scale that you and I actually live and work in. You know, how much water is in your backyard? Where that's exactly what we're going to try to answer, but on the moon. I didn't say this, but we are planning to launch in 2023, November 2023. So that's in a little more than 2 years. That seems like a long ways away, but when you're building a rover this big, it's about an 800-pound rover. It takes a long time to get all the design done, the pieces and parts. You saw the testing that has to go in to make sure you're building it and designing it in the right way. So we're working really hard, really fast to get this done and built as soon as we can. And with that, thank you. And yes, if we see any dogs on the moon, we'll be sure to let you know. This dog is, again, doing what we're doing, going to the moon and digging, looking for water or bones or something. I don't know. Actually, it's my dog. All right, so let me go and see if I can run one of these movies, at least from the desktop. If this doesn't work, then that's okay. All right, so here you go. Here is the rover driving. This is the rover. This is pretty much max speed. The rover drives, I'll do it again. The rover drives actually pretty slow. It doesn't want to go very fast there we go. Just because we're driving so far away on the moon. We don't want to drive too quick and accidentally get stuck in a crater. So we drive, take lots of pictures, make sure it's safe, drive some more. And then I can show you one other of it going up that steep slope. Here it is going up that steep slope. Again, it looks flat, but that's because the camera is mounted to this. So you can see it's slipping. You can see it digging into this soft material. We really push it to the limits. Later, they took one of these big rocks that you might see over here and stuck it in front of the wheels just to see how it would handle a rock if it was going up a steep slope. So this is the fun stuff. This is the best part of being at NASA and doing this stuff, is building really cool hardware and getting it ready to fly in space. So with that, I've got one other video that I can just start to play in the background, but that's it. That's really pretty much all I wanted to say at this point. Here, I can show this. This is the animation that will show that what the actual rover looks like when it's completed. It should just drive up and park right in front. Yeah. So what you can see here is it's got this mast, and he's got two cameras. These are its eyes. Kind of reminds me of WALL-E, if you ever saw that movie. It's got these two eyes here, and it uses that as stereo vision. That's how it sees in 3 dimensions, 3D. This is that nose, that instrument I said that measured hydrogen, smelled for hydrogen. That's it, sticking right out in front like a nose. And so it is really going along, sniffing right in front of the rover if there's hydrogen or water in the subsurface. Back here, this little kind of tent here, that's the top of the 1-meter drill that hooks up to the top. It comes down and drills underneath the rover when we want to. It's an all solar panel. These are solar cells. It's a solar powered rover. So kind of like the MER rovers, the Mars exploration rovers on Mars. It's about the same size of those and also uses solar power. So with that, I think that's all I have to show, but very happy to answer questions.
Thank you so much, Tony, for this amazing, amazing presentation, and looking forward to, in my lifetime, having, people on the moon. So with that, we're going to go ahead and get some questions answered. Looks like Allie has had her hand up, so if you want to go ahead and unmute yourself, you can ask your question.
If you're gonna start in 2023, do you know how long it will take you to find water on the moon?
That's a good question. How long will it take us? The mission plans for operating 100 days. And that's basically the entire summer at the south pole of the moon. Right now, after we land, we drive to one of these permanently shadowed craters, and we get there in about 3 days after we land. So we land in an area that's really nice and bright and lit, because it's easier to land where you can see where you're landing. From there, it takes us about 3 days to drive where we think we're going to find water. We don't really know for sure, but we're driving to where the conditions, it's cold enough for water to exist. So I think we'll know probably 3 days after the mission if we're going to find water. But we'll keep looking for another 97 days. Even if we find it there, the idea is we want to map it out to really understand the distribution of water. Good question.
Okay, Ryan, if you want to go ahead and unmute yourself, you can get your question asked.
Why are the NASA people are building rovers to find water and the moon and Mars? That long ago did it had like water?
So that's a really important question you're asking. That's one of the most important questions, is where did the water come from? And one of the ideas is exactly what you said. A long time ago, shortly after the moon formed, it acquired water. And where that water came from, there's a couple ideas. One is from comets. Like comets, like a big dirty snowball in space. They might have impacted the moon and delivered water to the moon, giving the moon water. Some ideas also include volcanism. Volcanoes on the moon might have outgassed or released water to the surface of the moon. Why those questions are so important is it tells us something about how we on Earth got our water. And so if we can understand how the moon got its water, we might actually better understand how the Earth got its water. So this is exactly one of the reasons why we're sending robots to study water on the moon. Great question.
Thank you. How about Leah from Miss Vega's class? She raised her hand. Go ahead, Leah.
Does it have to be a water from moon related question?
I may not be able to answer it, but go for it. I'm fine.
If Pluto isn't a planet anymore, what is it?
Oh, that's a dangerous question. There's big arguments that have been started over that question between scientists. It would be a planetoid. If it's not a planet, it's a planetoid, which is basically you're a second place runner up to being a planet. And this is a debate that goes back and forth, back and forth. What exactly is a planet? What isn't a planet? I would say it's right on the line for Pluto, whether or not you should be a planetoid or a planet. For now, it's a planetoid, which just means something not quite a planet. And what makes it not a planet is in part things like its orbit around the sun. Is it in the elliptical plane? Does it look like the other planets orbiting the sun, or does it look like it was captured? And that's one idea. It got captured. It was just a space rock floating out there and got captured by our sun. So it didn't form like the other planets around our sun. So there's things like that people point to that say it's not an official planet. It's a planetoid.
Wow, thank you.
Very good questions. Maybe one more?
One more. Oh, we have so many good questions, I'm sure, but we're going to have to pick Arnav right now. Let's see, Arnav, you've been raising your hand for a while.
So, if you're searching for water, then what if the water is mixed with the moon dirt?
You know, that is a really important question that you've raised, actually. And one of the things we care about is whether or not there are other things in that water. So we need to, especially if we're going to use it for drinking, we want to clean it. And definitely there are other things in that water. One of the other things we discovered with the water is mercury. Mercury is a poison on Earth. We don't, and where I live in the Morgan Hill, Mountain View area, we don't eat the fish in the lakes because they might have mercury. So that we've seen mercury on the moon. So there are engineers working on how to clean the moon water. So if you want that clean glass of moon water, yeah, clean it first. But there's ways to do that, like you get the dirt and the ice all together, and you heat it up, and just the water vapor comes off, and that's clean. That's called a distilled water. You'll see that in the store. You'll see distilled bottled water. So that's one idea that they're working to get it clean on the moon.
All right, all right. Okay, so now this is when we all turn on our cameras, video cameras, and we're gonna take a picture with this incredible guest of ours. Did you guys enjoy his talk? Amazing talk. Hey, thanks so much. This is amazing. Haven't talked to you in a little while, so it was really good for you to join us. Everyone, please turn on your cameras.
Good to see you.
Yeah. Please open up your cameras, please, so we can take a photo with our incredible speaker today. Okay, Andrea, Alfredo, Kevin, and Ryan. Okay, Andrea, Alfredo, Ryan, 5 more seconds. Okay, everybody, big smile, big smile. Don't put your hand on the camera, just a big smile. Okay, ready? Okay, 1 second, 1 second. Okay, now hold on. Let me see how the photo came out. 1 second. Hold that big smile. Ah, that's pretty awesome. Okay, well, let me see. 1 sec. One second. All right, so once again, thank you, Tony, Dr. Tony Colaprete, our planetary scientist for the Viper mission. What an incredible mission. Please look him up. Google Dr. Anthony Colaprete. He's done amazing work, okay? So he's one of our great scientists, planetary scientists, and he's here at NASA Ames Research Center, not too far from your school. Remember, we're doing this because we need all of you to do well in school, to go to college. And when you're in college, you can come and help us. And then when you graduate from college, you can come and work with us. Look at Mr. Colaprete and myself. We really need your help. How many of you did your homework last night? Raise your hand if you did your homework. Okay, not everybody's raising their hand. Okay. Now remember, you have to listen to your teachers, all the staff at school, and we're gonna be going back to school soon as it's safe. But for now, listen to your teachers, listen to your parents, okay? Do well in school. Be good community citizens so that when you grow up and you go to college, because all of you are gonna go to college, right? Because we need you. We need everybody to come in and help us, okay? So we're gonna do this again next week. Remember, we're doing this because you're all special. And we're gonna have some other really good speakers next week, okay? So come back next week, Tuesday, Wednesday, and Thursday. And we're gonna have other talks. For now, we're gonna sign off. Thank you very much. Thank you, Tony. This was amazing. Good to see you again.
Likewise. Thank you all. Thank you all. And you're absolutely right. We need you. We'll be on the moon when you're getting out of college. So perfect.
Yeah. Awesome. All right, everybody. Go finish your schoolwork and do your homework tonight, okay? Have a good night. Stay safe. Take care, everybody. Bye-bye.